One controversy in the database world is how to handle nulls, how to handle optional data. Some database developers use nulls like they're going out of style. Other database modelers never ever use null, feeling that nulls are a lazy man's way of cheating in the database. And these are very emotional feelings people have about null. First off, though, let's talk about what is optional data. If you think of the name suffix type of column, where you would normally put a junior or a senior or, John Smith III, that's a column that will be easily understood as an optional data column. Very few people will need something there, but you have to have it. Another good example would be an address to line, where most rows won't have an address to, but for those that do, you have to have someplace to put it. So the question then is, how do you handle this optional data? The typical answer is with a null. Null specifically means unknown, but to give it the definition of unknown just begs the question of why is it unknown? It could be several different reasons. That it does not apply to this particular row, that it doesn't apply now but it will later, for example like a ship date. You may not know the ship date before it's actually shipped. It applies now but it's not yet captured. For example, a new employee who is hired who should have a Social Security number but has not yet been entered. Another time when people use null is when it's correct that there is nothing there, for example in the name suffix. It does not apply now, it never will. Some people incorrectly use null when they really mean zero. Another problem of just dealing with null, besides the fact that the meaning is vague, is that it takes special work to code around null. For example, the is null when you're testing for it in a where clause, the is null function when you're retrieving a null and you want to replace the null with something else, the coalesce, which is another way of handling nulls in a function, and a null if, which will take a specific value and replace that with a null. The reason why we have to have all these different workarounds to deal with a null is because null means unknown. So if you take a formula like 2 plus null, well, there is no answer to that. The answer is going to be null because if you add an unknown, you don't know what the answer is going to be. If you do a comparison and you say, find where this is equal to null, well, it's unknown. You really can't find that. You can't even say one null is equal to another null. For example, if you have one box and one bag and you don't know what's in either one of them, you can't possibly say that they're equal. So null creates a lot of problems, and there's good reasons why people who avoid nulls avoid them. But if we can agree that there is a problem of optional data and it has to be handled, there are only 3 possible solutions. The first one being a nullable column, meaning that you actually allow a null to be written in the column, and when you retrieve that, you're going to see the nulls. The second option is a surrogate null, where rather than actually setting a null flag inside the database, you decide upon some surrogate, either NA or an empty space or an empty column, a 0. In the news recently, there was a story about a 2-year-old baby who was selected for jury duty. And the explanation on why she was selected is because when the birth date was unknown, they would put in July 4th, 1776. As a surrogate null for a missing birthday. And then someone ran a report and said anybody who's older than a certain date, and she came up. So even surrogate nulls sometimes cause problems. And a problem with a surrogate null is that it becomes very messy over time as different developers use different types of surrogate nulls. And I've gone into database projects having to clean up data where you had dozens of different types of surrogate nulls, and all had to be converted back to a single column representation before the data could be fixed. One that I call severe method of dealing with the optional data is one that I call missing row. Similar to a supertype subtype pattern that we saw a few moments ago, the missing row actually breaks out any nullable or optional data column into a separate table, builds a one-to-one relationship, and then stores only those rows that have the data. If you think about this for a moment and think about how you would query this kind of situation, it can cause a lot of problems. Let's take a table that would have, say, 8 optional data columns. Instead of having one table, you now have 9 tables. And every developer writing queries has to know the schema well enough to be able to write queries with 8 outer joins. And if they don't get those outer joins correctly, you're going to be missing data. So while the missing row pattern does avoid nulls and does avoid surrogate nulls, it introduces huge problems as far as performance and actual data integrity, meaning you get the correct answer to the query that you intended. To summarize managing optional data, there's the missing row, which gives you questionable data integrity, horrible performance, very difficult to understand. There's the nullable column, which can give you good data integrity, can give you good performance, it's easy to understand, but the problem is you have to handle the null with your code. Then the surrogate null, which can also give you good integrity, good performance, and because it's often inconsistent, will give you poor clarity.